Okay, I'll keep this kind of quick. Short presentation here just to kind of describe the small-scale plastic recycling work that we have done, kind of show what other people are doing, where we got inspiration from. And then for the rest of the day, however long you guys want to be here, I would love to just kind of walk around and show you guys specifically the equipment. And we've got a couple of demos that we could do. If anybody's interested in this, I'd love to do it, or you can just do it on your own. These are just plastic bags that have been ironed together, kind of building up to make something a little more durable. Groups that are doing this in kind of these lower developed countries, and they're actually using them as tarps or sleeping mats or something like that. So there is a real application for this. If anybody is like a talented sewing machine, which I'm not, there's been some pretty cool work where people are making like reusable shopping bags out of shopping bags. It's kind of neat. It's really accessible. It takes almost no investment. We're just using parchment paper and my iron from home. Another thing that you may or may not have seen is this kind of a substitute for food wrap cloth. Have you seen this? It's basically just a fabric that's kind of been coated in beeswax. I've got materials if you guys want to make one of these and take them home. Happy to do it. It's a really easy process too. So we also have some plastic welding equipment and some glue. We're not going to have time to talk about everything, but Evan put a lot of work into practicing plastic welding. And these are just ways of repairing plastics so that if if you've got a water tank or you've got like a fuel tank on your lawnmower or something that gets a puncture in it or a big tear, or you just want to do some crafting and actually build up pieces of plastic, then welding is definitely a technique. It's not real pretty. It's hard to make pretty, but it does work. I've also got our injection molder, which if you guys want to make something on the injection molder, we'd love to fire that up and show you. Got our shredder over here that it's kind of maybe just fun to watch it for a second. I love it. The shredder is like so visceral, you know. We also have outside this odd looking thing here is called the waste bot. That's not our name. That comes from a guy named Ben Peterson, I think is his name, Ben Peterson. And he had a group called Victory Gas Works who did a lot of small-scale experimental gasification work. So what this can actually do is take plastics and heat them up, similar to how we make biochar. You can heat up plastics. These are the dirtiest plastics, the stuff that has food waste on it, or paper labels, things that are really hard to recycle. And we'll actually make a gas out of that plastic and then inject that gas into a hot core of charcoal, which effectively takes these really weird long chain hydrocarbons and breaks them down into their elemental carbon and oxygen form. And what you end up with is carbon, hydrogen, oxygen. And you end up with this really hydrogen-rich gas that you can burn cleanly, or you can do even more interesting things like filter it and run generators off of it, or even more interesting stuff, actually collect the condensate from that process. And this is lab, farm, DIY scale plastic to fuel technology. So pretty interesting stuff. Definitely wanted to talk to you about that. Anyway, so I wanted to just kind of let you guys know what we've got and what we're doing with it. And then if you want to play around with it for the remainder of the afternoon, I'd love to. Okay. Plastic recycling is a little bit more complicated than you might think. You start with the product, you got to collect it, you got to sort it, you got to wash it, shred it, form it, and now you've got another product. Each one of those steps has tons of nuance. But in terms of DIY, R-scale recycling, that's kind of what we're looking at. Who's heard of this concept, the circular economy? Okay, have you guys seen these kind of diagrams called a butterfly diagram? This is just, it's not real pertinent to what we're doing, but it's a way of saying, okay, these have got to be our priorities. These small circles are like the priority. If you've got what they call a technical nutrient, this would be plastic would be a technical nutrient. And what do they call these? Biological nutrients would be something that you can compost. So remember that monstrous hybrid. There's the difference between what can be recycled and what can be composted. The technical nutrients are what we're talking about. Obviously, you want to maintain it, reuse, repair, refurbish if you have to. Refurbish implies that you're sending it back to the manufacturer. They fix it for you, put it back on the market. Recycle is kind of a last step. The opinion, we still don't want to be looking at recycling single-use plastics if we don't have to. Let's talk about making these plastics into durable goods that are worthy of repairing, worthy of sending back to the manufacturer. Recycling, again, being kind of a last step. The very last step, if you cannot recycle it, is to try to reclaim energy out of it. If you can't do that, then it goes to the landfill. We're talking about small-scale recycling, which you just heard was a presentation on kind of status quo, conventional recycling. And we're small-scale. I think it comes with inherent advantages. We're a little more nimble, and we can respond to different feedstocks. We're designing equipment that can respond to different feedstocks. Now, it may not be like a choice quality product when it's done, but we're experimenting with that, trying to see what can be done with whatever's coming in the door. Now, again, like I said earlier, that we could actually recycle PLA here when conventional cyclers won't go anywhere near it. We're dealing, as long as it's in a small enough batch, that it doesn't overwhelm us. So potentially, we could maintain the purity of single feedstocks, respond to niche markets. If there's something that's needed here in Asheville, or if there's something so small that it's hard to find a manufacturer to build it, that's the kind of thing that we might be able to do, small being like a small market globally. We know organic agriculture here, so we're going to explore those options for niche markets. Again, lower capital investment. I don't want it to sound like I'm just kind of hating on the current system, but the idea of pulling ag film from across the street and cleaning it and sending it to Ohio to make blocks is just kind of absurd. Let's be real about it. That's what we're talking about is, in a sense, the recycling industry is enabling the use of single-use plastics. All of this effort that goes into finding a use for ag films also says, hey, we're recycling ag films. Let's go with ag films. Which we know is kind of, especially as organic growers, we kind of know that there's better options. Okay, now we get away with we got a certain amount of leeway because we're small here. But, okay, if we did it, and they did it across the street, and they did it in their basement, and you did it over here. Now we've got a system where there's a lot of people that are kind of skirting under the radar, doing small stuff. Our wastewater is going to be an issue. If we want to scale up at all, we're going to have to be dealing with wastewater. Another thing is, I don't know, you saw us pack that mold and look at all the little flakes of random plastic that are now on the ground since we did that. Those boards, I'm taking those boards, I'm cutting them with my skill saw, to see. And I don't know, man, it's not sawdust. It's not going to just go away. So in a way, we're actually directly responsible for generating microplastics. So cons of small scale is we've got to be super clean. There's nobody coming in to tell us to be clean. We're just so small that we're under the radar, and you kind of just have to be responsible for that stuff. Obviously, it's very labor intensive. Scaling up capital investment is where you kind of overcome labor costs. If we're going to be doing small scale stuff like this, it means we're going to be doing it. So it requires this immense broad knowledge. The more polymers you bring in, the more processes you're trying to figure out and do yourself, just means that you got to know how to do it yourself. Especially you got to know how to protect yourself. I mean, those are things that we need to definitely get in line if we're going to be doing this for the long haul. There's case shredding. So we've collected the plastic. It's here on site. These are the shredders. Now, most of this is coming from a group called Precious Plastics. There's a designer, artist guy in the Netherlands that kind of made this his project some years ago, 5 years ago maybe, something like that. And it caught on really fast. He released a set of plans, maybe collaborated with some engineer friends of his, and released a set of plans and made them available for free. This is how you build your own small-scale plastic recycling equipment. Now, that stuff has improved quite a bit over time. We're dealing with the version 2 equipment. There's already been a version 3. And now they're working on version 4 right now. Each time they're making improvements, and version 4 should be out pretty soon. They'll release the new plans out on the web. So we're already kind of dealing with some stuff that's already been improved upon by either the Precious Plastics Group themselves or the wide range of contributors that they have. Anyway, so this is the shredder. Kind of a side view of the teeth here. That's our shredder. We got this motor from the junkyard. Down here, that's a 3 horsepower, 120 volt motor, actually. So that's a big 120 volt motor from the junkyard for very cheap. We did buy the gearbox. We did buy that linkage. And we had a friend of ours with a plasma cutter was able to cut the blades for us. That helped us out quite a bit. We paid him $100 for that. So we got the costs down pretty good on that. I want to say we maybe have, realistically, probably $500 invested in this. So the shredder is neat. It shreds plastic. It's optimized for shredding plastic. It's optimized for shredding like bottles, regular household plastics. Our kind of industrial, kind of semi-industrial ag stuff, it's not really optimized for that. I'll just say that right now. But this teeth design is nice because it takes a rounded, blown bottle and can kind of like grab it and pull it under, you know, where in other kind of systems it might just sit there and bounce. Happy to demo that later. This is pretty neat. Okay, what we're looking at here, and this kind of opens up a wide range of possibilities. This is something that we wanted built into the design from the start was, okay, we've got money invested in the gearbox, and we've got money invested in the motor, and the linkage, that's a universal linkage. We want to be able to run other things on it. We might not be running like shredding plastic. We're not going to do that every day, all day. You know, we want to be able to use it for other small farm or small fab shop activities. So Evan fabricated this tumbler that can run off of it. So now what we're doing is actually mixing our own green sand for casting projects. So you can take bentonite clay, just actually kitty litter, am I right? Yeah, kitty litter and sand, and you can make your own green sand, which is, if you've ever seen, green sand is the moldable sand that you can pour molten metals into for kind of a rough casting. One example of it. Now, you know, we haven't built this, but we've definitely put some thought energy into it. A roller mill for like a grain mill type thing. You know, that's the kind of small attachment pieces that we can add to this system. Okay? So it kind of opens up possibilities for making those things affordable to small farmers. One thing that shredder is really good at is shredding leaves. So we shredded a bunch of leaves when we did this briquette project. We shredded cardboard to do this. Apples, if you throw an apple in there, it'll just fall through like water. I mean, these are all things like not every farm needs an apple scatter, apple press system, certainly not 52 weeks out of the year. So what we're trying to do is develop modular equipment that we can do all kinds of processes for and get that cost way down. Okay, this is a compression molding system that from Precious Plastics. What we're looking at is the up top, that's basically an oven. You know, he has a video where he goes out and grabs an old electric oven from the junkyard and puts an automotive jack underneath it. And it's just like that. It's got something fixed that it's pushing up against. So you build a mold and you push up against it. He's done some really nice things. He made a mold for a little trash can there. You know, cool stuff. It's really clean. It's also kind of electrically, it's intensive. That's a lot of electricity. But it is very fine-tuned, and he can hit a target temp. He can say, I want to heat that to 220 and keep it between 220 and 222 degrees. These are some interesting projects with compression molding. This one on the left, I mentioned it earlier, is a little roll-up chest mat that somebody made who's more talented than I, using plastic bags, fused them together, just like I did with the iron, cut them into strips, sewed them back together, and each one of these chest pieces are actually injection molded on one of these machines. So definitely got some potential here. This machine on the right is the inspiration. Mark Burtbach is the guy who designed that and made it available on the Precious Plastic forums. That's our inspiration for our compression mold system. He's making these boards in a pizza oven. I think this up top is, yeah, this guy just bought a little sheet press. So he's trying to find ready-made equipment that he doesn't have to build to do this. He's making some really nice pieces that are obviously pretty small, but they're really nice finish, like making some beautiful pieces. That's my bag experiment. I'm really trying to make that easy as can be. So I took a big bag and stuffed it with a bunch of small bags and just ran an iron across it to see how it would act. And, you know, it's okay. It's not great. There it is. If you want to try to get a feel for that, try to tear it. It's hard. This is the board that I showed you guys earlier. This is us trying to prepare that board. Again, the idea is trying to make this as simple as possible. This was one of those big plastic containers that we probably could have recycled this one, conventionally recycled it. It had a lot of holes in it, and we were having a hard time making it watertight. We tried to weld it and fix it, but we just, like, so many holes, and we thought we had it, and it still leaked, and we just kind of gave up on it. Again, that's the same process where I tried to sprinkle some little flakes on it to give it some color, and you kind of see what we ended up with there. Injection molding, okay, we recognize that. That pretty much looks like ours. Here's some projects people are doing. Okay, here's the chest set thing that I showed you earlier down there in the bottom. These are the tiles that I mentioned earlier too about being able to take all, you know, when we were doing the demo on identifying plastics, those guys are taking basically all 6 of those commodity plastics, putting them together and making tiles out of them. And I think that's in South Africa, I think, somewhere in southern Africa. And they've got some sort of a deal with a community center there where they're doing a big art installation, just doing wall tiles. And that's their mold up top. So these guys are they're making beautiful aluminum molds. This machine up top in the middle, he actually made those eyeglasses on that, which is pretty sweet. They added this hydraulic action so that they could get the pressure up. You know, our pressure is limited to what you can do here. You know, it's if I grab it there, how hard can I pull down? You know, and we're limited to that amount of pressure. Our plastics kind of have a unique thing where you can heat it, make it more liquid, and you don't need as much pressure, but then you kind of lose some of the physical strength properties if you heat it too much. So something like eyeglasses, you definitely want to kind of keep on the lower spectrum of heat. This is the product that we kind of started making early last spring. Maybe you saw them in the back, but this is our injection molded project. Little limb spreaders, and this is probably in March or, I don't know, probably at least March, because we got a little leaf out over there. I put them out on my trees in my yard, and here we are. This was this morning. And 2 of them are still there in the tree. More than 2 of them are there. But this tree, way down here, you see how there's one there and there's one there? Kind of down low. That's what we're looking at. When you look down on the trees, you can see, and I pulled this one off, which is actually this piece right here. Pulled it off the limb, and that limb is definitely at that perfect little 30-degree angle. You guys are familiar with limb spreaders? It's a process that tree growers, fruit tree growers, that what they want to do is make sure that they've got a strong angle, the right angle of limb to branch, because those fruit trees are going to be bearing a lot of weight of all the fruit. And we just kind of know that like a 30-degree angle is ballpark optimal. So some growers, professional growers or hobbyists, will go out and use little limb spreaders, traditionally made out of wood or something, and train the trees to grow at that angle. A super steep angle, you know the Bradford pears, they fall apart all the time. And then a 90-degree angle also can't bear as much weight on the end of the limb. So we were looking for an agricultural product. We made these out of milk jugs that came from Mills River Creamery. So Kendra, I don't know, is Kendra out there? Kendra kind of worked part-time with Mills River Creamery, and she started doing a milk jug collection for us. She delivers milk to restaurants and coffee shops. They save their bottles and bring them back to us. So we wanted to make something that was at least agricultural in use. As small and, small as it is, that's what's kind of unique about this small-scale plastic recycling, is that we may actually have a suitable market for that if we were to try to market those. Certainly over the internet, it's possible we'd have enough buyers that we could make sense out of doing that. Okay, the extrusion system is basically, imagine a pipe that has a screw running through it, and you're loading that screw, and as you turn it, it's pushing things forward. And as it gets to the end, it pushes it out a little nozzle or a die. And think of, the Play-Doh machines where you can make spaghetti out of Play-Doh. It's kind of like that, where you're pushing it through a die. And as it moves, the material is being heated, and then pressure is being built up right before it shoots out that die. These are some crafts that people are doing with the extruder from Precious Plastics. Some really beautiful stuff. This guy made a little wood mold that he's made this, either a lamp or it's a hanging flower pot. It's kind of like whatever you want to do with it, We've got some bowls that I made in the back in a really similar process. Just kind of took a bowl and just formed plastic around it. Our stuff isn't looking quite that nice. Of course, you can't really see that up close. I don't know what kind of texture they're achieving, but it's probably the extruder above all is probably getting the most criticism or has the most room for improvement on the Precious Plastics work. What attracted me to it was like the availability of the materials. You can just use a wood auger bit that you can go to the hardware store and buy like right now for relatively cheap. It's in that bit that you're really kind of running into the problems. You can't build up the pressure that you can in a professional extrusion system. It also kind of just moves material too fast through there. So we're having a lot of different problems. A lot of people want to say, oh, can I make 3D printer filament? It's probably impossible on that machine. But there are a lot of people that are trying to make improvements on that machine. And the version 4 machine, no doubt, will be well improved upon. This is built on the version 3 machine where he's already got a nicer bit. And this is the guy who started this Precious Plastics thing. And he's showing how you can make really long beams, which, of course, if you can make beams, then you can do all kinds of interesting stuff. Those beams take a long time, like a long time. I'll show you some examples of beams we tried to make on our system. That's ours right after we painted it. And this is, again, in the spirit of multi-machines and not having it for one purpose. Remember those maggots that I told you we were going to come back to? Those are maggots that we blended with oats, and we actually made a extruded animal feed pellet from those that we can later dry, and then we can take those pellets, and now they're shelf stable. So it's a pretty high fat, high protein, very high protein, very high fat pellet. Now, I didn't really do the feed analysis on it or anything, but we proved that it is feasible to do on that machine. It's actually like very feasible. That was easy and definitely did not stress the machine out at all. So now we've got a machine that can, make your own animal feed, custom blends. It's interesting. I feel like that's when we're really getting into something interesting for the farm use. I included this picture. This is while I was making one of those bowls, just to kind of give you an example of some of the defects that we're dealing with. If you look really closely, this is a kind of a melted, semi-soft band that's coming out of the extruder, which would have been up there. And what I'm doing is just wrapping it around a bowl. Look real closely. You can really see it when it's still translucent and hot. A lot of little air bubbles in there. That's definitely a result of not getting the pressure up. This is probably the place that if I was going to make a recommendation to, I don't know, the city of Asheville or whoever that does waste management around, I would say let's find something that works on this scale. Now, this is called the ABAT. Now, it's a much more professional system that is an extruder that you fill up with flakes of plastic. And it makes a fine enough strand that you can actually use it for 3D printers. So this machine is kind of marketed towards people that do 3D printing, and they need exact specs, and they maybe do a lot of 3D printing and want to start to reclaim plastics with their material. This would be a sweet system for a large community to invest in. It's only like $3,000 or something, which is a drop in the bucket compared to some of these other systems that we're talking about. A system like this makes, I don't want to get into too much about 3D printing, but there's a lot of potential there in terms of making manufacturing accessible to all of us, being able to repair things, build our own equipment, Kind of makes us all inventors again, which is sweet. This is a way to use small batch plastics that wouldn't otherwise be recycled into making something that can really have an impact in a community. This is the perfect kind of collective machine, you know. Some lower tech alternatives. This is a group I just wanted to kind of show for a second. Doing something as simple as taking a bottle and shoving it full of plastic bags. The thing that I didn't really get researching this was where they're getting all these bottles from that are uniform shape and size. You know, my guess is maybe like I don't know, Red Cross comes into a community or FEMA comes into a community and there's like a whole lot of single-use water bottles. You know, this would be a nice option for that because that's definitely what happens, you know, when they go into a community and they're sending water bottles. They're not, you know, for short-term water. And there's a lot of plastic left over from that process and there's a lot of plastic waste everywhere. So what these guys are doing are stuffing these bottles and kind of basically ramming them as hard pack as they can. And then what you can't see that they're doing here is taking like 12 bottles and then gluing them together in this configuration that bottle, you know, can all be lifted up as one unit. And then you can kind of start to stack them like you would Legos. They nest in each other, which is kind of a neat innovation. You know, there's also even lower tech where you're kind of stacking them and making walls out of them, kind of just using them as filler material. The idea is that you're just tying it up, you know, so that it's not degrading anymore. You might be getting something useful out of it. Debatable how useful it is. I mean, I don't know how strong a structure like that's really going to be. That's for another workshop. Here's an even kind of improved upon method, you know, kind of a engineered method where you're taking it and lining it with like a mesh wire and then using that mesh wire for concrete or stucco or something, which is kind of a neat thing. Another way to just tie up what's out there. Okay, and I did tell you about the waste bot, so I just wanted to give you kind of a cross-section. Remember the waste bot's this machine out here that can take dirty plastics. Our little experiments that we're doing here all the time, we're always ending up with these little nuggets of stuff that we can't really use, and of course the conventional recyclers aren't going to go anywhere near it. You know, why would they? Stuff that's been burned, or again, if we're bringing in plastics and it's just so gross that we don't want to bother trying to clean it or peel the label off, then that can go into the waste bot. And this is 2 chambers going on here. One is full of charcoal, which is kind of convenient for us, being a biochar plant and all. And the other one is filled with waste materials. So it's not just plastic. You can put plant matter in there. You can put food waste. You can put manures in there if you wanted to. And then what you're doing is just, you're heating that in a limited oxygen environment. Those gases are forced through this tube. And in this chamber, those gases, again, those complex plastic gases, are being hit by 1,000 degrees plus Celsius, very hot temperatures, where they're starting to break down there. And then what's interesting here, this is kind of like an oxygenated zone. And then you have this like very low oxygen reduction zone, where these gases have to go through across the intense heat. And then they go through this oxygen limited zone where oxygen atoms are being pulled off. And then you're further reducing those gases into their elemental forms. In which case, those gases are nice and hot now, and they're going across this chamber, heating this chamber all the while. So we're starting this process by just burning charcoal, gasifying charcoal. And then the plastic gases are then generated as this heats up, and then it kind of continues the process. Now, it's a batch system, so that has to happen in a limited amount of time. What we have, I'll just admit it, I'll say it straight, we've had trouble getting this chamber hot enough, for one, and we're running through the carbon too fast. So if we want to get this hot, we've got to go full throttle on this. If we go full throttle on this, then we're out of carbon by the time this is hot. So what we're finding is that we have to reload the carbon multiple times during a burn. We've only been running this thing for a couple of weeks, too, so we've still got a lot to learn. It's all very DIY too, which I love it. We made that machine for, I think we've got $800 invested in it. So much of that stuff comes from the junkyard, you wouldn't believe it. It's amazing how much we've been able to source at scrap value. If you kind of want to get a sense of how it works, I'm happy to show it. Right now, heat is the output and a small amount of hot water. Now, we can do a lot with that heat. We can also just use it as gas. All of this, we're just kind of building up to. This is from the WasteBot frequently asked questions page about how it works, and also kind of gives you a little bit of a description on necessarily why it's better than just open fire, plastics burn, or conventional incineration. This is not how conventional incineration works. It's quite a bit different. That's the waste spot in action. That was the first day that we ran it. That's the kind of flame that you're getting. Now, it looks like it's on fire, but it's not. It's just the way I took that picture. That is kind of the brilliantly clear, clean flame that you should expect out of that. Okay, so kind of a recap of what we learned here today. We're no longer just reduce, reuse, recycle. This is just kind of a clever play on words. We learned about redesign, the 5-gallon buckets, designing for reuse. We certainly learned reduce and reuse. Everybody knows that. Wanted to show some repair techniques. Still happy to do that. Refurbish, recycle, retort. That's what we're calling that. That oxygen-limited chamber is called a retort. And remove. Remove from the environment. Tie it up. If that's the method for getting it out, that's what we'll have to do. That's it.
Thanks, Dan.